Hi students, this is the second video on inequalities and it's going to be primarily for word problems. These are some key word for word problems. I like the idea of knowing them. However, they only work if the variable is on the left side. You have to have an instinct of actually reading all the words on what's going on too. Inequality word problems are different from equations because you have to make sure that you choose the right inequality symbol. And if you don't, then all in your whole inequality that you created, this like the inequality, not equation, but the like 5x is greater than 20 that you create, the answer will be all wrong after that. So the symbol is equally as important as setting up the variable and the numbers in that combination. So greater than, typically you see more than, greater than or equal to, you'll see greater, at least, minimum, no fewer than, no less than, less than, fewer than, less than or equal to. Another one I can add on to this is maybe maximum, I think. Again, these are just some of the words that I see, but you really have to like kind of making sure that you understand. If these are word problems, make it logical. Common sense goes a long way with inequality word problems. So let's do we have two examples. I am going to solve it, like to help us make sure that it actually makes sense. Sometimes solving the inequality will help. So a cargo elevator has a maximum carrying capacity of 240 pounds. Each cargo box weighs 20 pounds. Write and solve an inequality that represents the maximum number of cargo boxes the elevator can hold. So as always, you should always identify your variable. And in this, our variable can be B for number of boxes. Okay, and for the inequality symbol, a lot of the times, I'm just going to put this box here. Maybe I'll just make it a lighter color. I'm going to make it yellow, which you can barely see. What that just means is that we're not sure what symbol we're putting in there right now, and sometimes it helps to do it after you put all the numbers and the variables in, okay? So a cargo elevator has a maximum carrying capacity of 240. Each cargo box weighs 20 pounds. So do we have a rate that's going on? Remember, rate means something like miles per minute or things like that. Okay, there is a rate that goes on here. Each cargo box weighs 20 pounds, and our variable is B, which is number of boxes. So you're going to have 20B somewhere here. So like if you have one box, it's 20 pounds. If you have two boxes, 40 pounds. Okay. And the only other part of this information, only other thing that gave you is that the cargo has a maximum carrying capacity of 240 pounds. So that's kind of representing your total. So it's on the other side of your inequality that we haven't chosen yet. So now what's saying is a maximum carrying capacity of 240 pounds. So what you're asking yourself is, this 240, is this the highest or the lowest number it can be? And that means the boxes in the elevator have to be less than that. That's why you're doing less than. And can the elevator hold exactly 240? And the answer for that would be yes, it can. Why not? If it's a maximum carrying capacity is 240, that means it can carry 240. So whatever's on the elevator, which is on the left side, with the boxes, has to be less than or equal to 240. And now let's solve this equation, this inequality, to see if this makes sense. So this is multiplying, so we're going to divide 20 to both sides. And we're going to end up getting B is less than or equal to 12. And let's see if that makes sense here. Can you have, if you had two boxes, how much weight is that? That is 40 pounds because each box is 20 pounds. Let's go on the other side of it. Like we're saying is less than or equal to 12, but can you have like 15 boxes? Well, if you had 15 boxes and you multiply that by 20, you're going to end up getting 200, nope, not 200. I did something wrong. 0, 1, 300 pounds. 300 pounds. And you cannot have 300. So this inequality symbol of less than or equal to is correct. And if you did end up having, like, choose a number that fits your inequality and see if it actually makes sense to the problem being asked. Okay? If you ended, what I mean by that is if you ended up having greater than or equal to instead, 15 wouldn't make sense in this, and that way you can switch it around. Okay? Let's do another one. Frankie has $400 in her bank account at the beginning of the summer. She wants to have at least $150 in her account at the end of the summer. Each week, she withdraws $22 for food and entertainment. Write an inequality for the solution. Let X represent the number of weeks she withdraws money from her account. So X is number of weeks, okay? And now let's create this inequality. I'm going to put that box again because I happen to like it. If you're not sure of it, why put a symbol in there? So let's look at what they're telling you. Frankie has $400 in her bank account. So that is a constant, not a rate. Nothing is affecting that directly, okay? At the beginning of the summer, she wants to have at least 150. That's another constant. And that's what she wants at the end, okay? So that's another constant. So these are things you need to think about. In her account at the end of the summer, each week she withdraws $22 each week. So this is your rate right here. So that means she's going to have 22x. So starting off with 400, and every week you are subtracting 22. So 2 weeks would be 44. 3 weeks would be 66. And that's what's going on here. That means you want 150. She wants at least 150. Let's think about that. At least 150. Is it going to be greater than? So this, at the moment, has to be greater than this. She wants at worst $150 in her account. If she has $100 at the end of the summer, that's not fulfilling this inequality. So that's why this has to be greater than whatever she has left, whatever she spends in the summer, okay, has to be like, she has to spend less than what she has, okay? So now let's solve this inequality to see if it makes sense. So I'm going to not add that. We only have one variable term, so I'm going to subtract 400 from both sides, which is fine. Remember, the 400 is positive. The 22 is negative. So this goes away. We're going to have negative 22x is greater than or equal to negative 250. Divide negative 22. And that gives you x is less than or equal to 11.36. That's what the decimal ends up being at. And remember, why are we flipping the symbol? It's because we divided by a negative on both sides. You got to flip that symbol. And let's see if this makes sense in context to the problem. So we have 11.36 weeks. Does 11 weeks make sense for this? In 11 weeks, so 22 times 11 ends up being 1 times 11 is 242. Okay, that's this part. 400 minus 242 is 158. So that fulfills a requirement that she has to, that requirement of that she needs at least $150 in her account at the end of the summer. So that greater than or equal to from the beginning actually fulfills the requirement. So this is true. Okay? Thanks for joining me on Word Problems. Bye, everyone.